Let's move to the last topic of module 6, that is recent trends in embedded computing. The embedded industry has evolved a lot in terms of many things like performance, miniaturization, features, development cost and time to market. So let's see some of the current trends and bottlenecks in the embedded development industry. So in this topic we will discuss about processor trends, operating system trends, development language trends, open standards, frameworks and alliances, bottlenecks and development platform trends. So first one is processor trends. So some of the difference between the first generation of microprocessor or microcontroller and today's microprocessor or microcontroller are, first one in terms of number of ICs per chip. So in first generation microprocessor or microcontroller, we used a few number of ICs per chip. Okay, but today's VLSI technology can pack tens of thousands of IC per processor. Okay, so there is a big difference in number of ICs per chip. Second one is need for individual components. So in older systems, all components are externally interfaced to the microprocessor or microcontroller, but nowadays all the components are on the same chip of processor. Then third one is speed of execution. The difference is in speed of execution. In older days, the processors were running at slow speed because it could execute less number of instructions per second. But nowadays the microprocessor or microcontrollers, it use pipelining, parallel processing, etc., and the speed is increased. Then next one is clock frequency. In older days the clock frequency were in terms of megahertz range, but nowadays it's in gigahertz range. Then application specific processor. In older days we used general purpose processors for embedded computing, but nowadays it is possible to custom create a processor according to a product requirement. Okay, so these are the main difference between first generation MUPI and today's microprocessor microcontroller. So the difference is in terms of number of ICs per chip, need for individual components, speed of execution, the clock frequency and application specific processor. And the major trends in processor architecture are, first one is SoC. SoC is system on chip. So SoC, this is a technology that places multiple function systems on a single chip. That is, all components for an embedded system in a single chip. So example, set-top boxes, media player, PDA. PDA means personal digital assistants, etc. are examples for SoC. So all the components for an embedded system are available in a single chip. That is called SoC or system on chip. So what is the main advantage of this? It saves board space, right? And of course the size is reduced a lot. Then second one is system in package or SIP. SIP means any combination of one or more ICs of different functionalities like a microprocessor, microcontroller or a SIC, SIP, RAM and flash memory. Okay, so any combination of one or more ICs of different functionalities, that is called a system in package or SIP. So the previous one, that is SoC, is built on a single silicon die, whereas SIP may contain more than one silicon die which are stacked into single package. Then third one is multi-core processors or chip level multiprocessor. So multiple cores on the same processor chip, that is called multi-core processor. So nowadays dual core processors, tri-core processor, quad-core processor, etc. are available. So each core implements pipelining and multi-threading, so the performance can be improved a lot. Then fourth one is reconfigurable processors. So this reconfigurable processors is to have reconfigurable hardware features. For example, it can be configured as the heart of a camera or that of a media player. So we can configure the hardware features of this processor, reconfigurable processor. So that's about processor trends. Second one is operating system trends. So different operating systems are available for embedded computing. So some are commercial or proprietary operating systems and some are open source operating systems. So we can choose among this commercial or open source operating systems according to our requirement. Then most of the operating system bring virtualization concept by replacing the monolithic architecture with the microkernel architecture. Microkernel architecture means only the essential services are in kernel and the rest are installed as services in the user space. So that is called microkernel architecture. So nowadays most of the operating system brings this virtualization concept into picture. Now next one is next trend in operating system is off the shelf operating system. So off the shelf operating system for dedicated devices are a new trend in this embedded system computing. For example, for this off the shelf operating system is Microsoft Embedded OS, and it's used in many embedded system applications. Then third one is development language trends. So there are mainly two aspects to development languages. One is embedded firmware and second one is embedded software. So embedded firmware means the software loaded in the embedded system that communicates with the embedded hardware. Okay, so the software loaded in the actual embedded hardware or actual embedded device, that is called embedded firmware. And what is embedded software? Embedded software is the software that runs on host computer, that is called embedded software. So initially, uh, the commonly used languages for embedded system development was embedded C, C++, etc. But nowadays other languages are used for embedded system computing like ASP.NET, VB, Java, etc. So we will now next we will learn how Java is used for embedded computing. So Java is actually, it's not a popular language for embedded system development due to its nature of execution. So we know that Java programs are compiled by a compiler into bytecode. Then this bytecode is converted by the Java virtual machine or JVM into processor specific object code. Okay, so first source code is converted to bytecode by a compiler, then bytecode to processor specific object code by a Java virtual machine. So during runtime, this interpretation of the bytecode by the Java virtual machine makes Java application slower than that of other cross-compiled application. So this is a disadvantage of this Java. It's slower than other cross-compiled applications. So this disadvantage can be overcome by providing inbuilt hardware support for Java bytecode execution. And another technique used to speed up execution of Java bytecode is using just-in-time JIT compiler. Okay, so we can speed up the execution of Java bytecode using a JIT compiler. So it speeds up the program execution by caching all previously executed instructions. So there are some methods to speed up the execution, but there are still Java has some disadvantage, and that's why it's not commonly used for embedded system development. And those disadvantages are, first one is for real-time applications Java is slow. That is the first reason. Second reason is garbage collector of Java is non-deterministic in behavior, which makes it not suitable for hard real-time systems. And third one is processors need to have a built-in version of JVM. Okay, so if the processor that don't have JVM, it's required to port for the specific processor architecture. Okay, so the processors need to have a built-in version of JVM, otherwise it should be ported to a specific processor architecture. Then Java is limited in terms of low-level hardware handling compared to C and C++. That is another disadvantage. Then runtime memory requirement of Java is high, which is not affordable by embedded systems. We know that embedded systems, the main consideration should be for memory. Memory is a big consideration. So runtime memory requirement of Java is high, which is not affordable by most of the embedded systems. Okay, so these are the reasons why by which Java is not a popular language for embedded systems. Then moving to the next, fourth one is open standards, frameworks and alliances. So this open standards, frameworks and alliances, in some of the open standards, frameworks and alliances in the mobile handset industry is given below. That is OMA, OHA, Android, Tizen and Open Moco. So first one is Open Mobile Alliance, OMA. So it's a standard body for developing open standards for mobile industry. So the stakeholders are leading network operators, device manufacturers, information technology companies and content providers. These are the stakeholders of this OMA, Open Mobile Alliance, and the mission of this OMA is to create interoperable service across countries, operators and mobile terminals by acting as the center of the mobile service enabler specification work. Okay, that is the mission of this OMA, Open Mobile Alliance. Second one is OHA, Open Handset Alliance. It's an alliance formed by various handset manufacturers like STC, Samsung, LG, Motorola, etc. Then also like by various chip manufacturers like Intel, Qualcomm, etc. And by some platform providers like Google, Wind River Systems, etc. and carrier like T-Mobile, China Mobile, etc. Okay, so this is an alliance formed by various handset manufacturers, chip manufacturers, platform providers and carriers for developing open standards for mobile devices. So this is Open Handset Alliance. Third one is Android. It's an open source software platform and operating system for mobile devices. Then next one is Tizen. Tizen is an open and flexible operating system based on the Linux kernel. And OpenMoko, it's a project to create a family of open source mobile phones including the hardware specification and the operating system. Okay, so these are some of the open standard frameworks and alliances in the mobile handset industry. Then fifth one is bottlenecks. So this section discusses some of the bottlenecks faced by the embedded industry today. So first one is performance, power optimization and thermal management. So achieving a right balance between these three, that is performance, power optimization and thermal management, is a big challenge in embedded computing. Okay, so we know that the performance of embedded system, we always want the performance to be uh, high, that is performance has to be increased and the power consumption has to be decreased. Okay, so that is our first motto, right? Performance has to be increased and power consumption has to be decreased. In order to increase the performance, we can increase the processor speed, that is one option. Okay, but if we increase the processor speed, which will in turn increase the power consumption. That means if the power consumption increase, means we have to use we have to increase the battery power. That means the entire size of the entire product increases. Okay, so all these things are related. So achieving a right balance between all these things is a big challenge. Then another area of improvement is enhancing memory performance. Okay, so we know that there is no point in increasing the processor speed without changing the memory speed, right? There is no point in increasing the processor speed beyond a limit if the memory speed is fixed. Okay, so this is the first bottleneck faced by embedded industry. Then second one is lack of standards or conformance to standards. Standards in the embedded industry are followed only in certain handful areas like mobile handsets. Okay, there is growing trend of proprietary architecture and design in other areas. Okay, so in other areas except this mobile handsets, we are using proprietary architectures. There is no common standard. So to bring innovations and cutting edge features or feature rich products, it is essential to have a combined effort and standardization. And third one is lack of skilled resources. So it's most important aspect in the development of embedded system, uh, that is the availability of skilled labor. There may be thousands of developers who know how to code in C, C++, Java or .NET, but very few in embedded software. Okay, so getting skilled resources is again about challenge in embedded computing industry. So these are the three bottlenecks faced by embedded industry today. And last one is development platform trends. The development platform is an integrated hardware platform which incorporates a processing unit, integrated peripherals, expansion boards, then debug interface for interfacing with a host computer for firmware development, etc. So some of the popular hardware development platforms are given, like Arduino, BeagleBone, Sharkscore, Minoboard Max, Raspberry Pi, Intel Galileo, etc. So first one is Arduino. Arduino is a single board microcontroller. The hardware consists of an open source hardware board designed around an 8-bit Atmel AVR microcontroller or a 32-bit Atmel ARM processor. So you can use the open source Arduino development environment Arduino IDE for developing applications. Second one is BeagleBone. BeagleBone is an open hardware community supported single board embedded computer from ARM Cortex processor based development. Third one is Sharkscore. It's also a development board for developing device drivers and reference hardware like tablets on Windows and Android operating systems. It is built around Intel Atom processor and supports various interfaces like I2C, SPI, UART, USB, etc. Then Minoboard Max is an open hardware embedded design platform designed with Intel Atom processor and supports various interfaces, the same as that of Sharkscore, and it is a powerful platform for small scale low cost embedded system design. So this Minoboard, its mainly its main use is in developing small scale low cost embedded systems. Then next one is Raspberry Pi. Raspberry Pi is a single board computer design platform developed by Raspberry Pi Foundation. It is used as an aid in computer education across the globe. It was designed with Broadcom SoC based on an ARM 11 core. And last one is Intel Galileo Generation 2 board. It's an open source hardware development board based on Intel x86 architecture and specifically designed for makers, students and educators. The Galileo board is based on the Intel Quark SoC X1000 application processor. Galileo board is also software compatible with the Arduino software development environment, that is Arduino IDE. Okay. So these are some of the development platforms used in the embedded computing industry now today. Thank you.